Tesla just did something that makes no sense. The company spent months engineering what appeared to be a breakthrough in robotic manipulation. They filed international patents protecting the design. Engineers described it as achieving near-human functionality, and then, right before the public reveal, Tesla quietly scrapped it and started over. This is the story of the perfect robot hand that Tesla built and then made obsolete before anyone outside the company could see it work. The Optimus 3 or Gen 3 reveal has been teased over the last few months, with new international patents published in mid-April 2026, detailing a tendon-driven hand with approximately 22 degrees of freedom per hand and actuators moved to the forearm for speed and precision. Electric vehicles. Those patents represent the culmination of years of robotics research compressed into a single design. 22 degrees of freedom is not a random number. It is the threshold where robotic movement starts matching human dexterity. To understand why that matters, you need to understand what degrees of freedom means in robotics. Every independent way something can move counts as 1 degree of freedom. Your thumb can bend at 2 joints and rotate at the base. That is 3 degrees of freedom just for your thumb. A human hand has around 27 degrees of freedom total when you count every joint and every possible movement. Tesla's patented hand design had 22 degrees of freedom. That means it could replicate nearly everything your hand does. Pick up a coffee cup without crushing it. Thread a bolt onto a screw. Handle delicate electronic components. Grip irregular shapes. All the tasks that make human hands irreplaceable in manufacturing and daily life. The main advancement from the past iteration will be human-like hands with 22 degrees of freedom tasty live. But the degrees of freedom only tell part of the story. The revolutionary aspect was how Tesla achieved those 22 degrees of freedom. The patented design used a tendon-driven architecture. Instead of putting electric motors directly in the fingers where they add weight and create bulk, Tesla moved all the actuators into the forearm. Synthetic tendons run from those actuators through the wrist and into each finger. When the actuator pulls a tendon, the finger moves, just like human anatomy. This design solves multiple problems simultaneously. First, it makes the hand lighter because the heavy motors are not in the fingers. Second, it makes the hand faster because lighter fingers can accelerate and decelerate more quickly. Third, it makes the hand more precise because the control systems can modulate tendon tension with extreme accuracy. Fourth, it makes the hand more durable because there are fewer moving parts exposed to damage in the fingers themselves. Tesla engineers recently highlighted that Optimus Gen 3 is nearing human form factor and functionality. The holy grail of this generation is the new hand design, which features 22 degrees of freedom. This allows the robot to mimic human movement with startling precision, moving away from a clunky mechanical look and instead resembling what one engineer described as a human in a superhero suit. No tet slap. That phrase, human in a superhero suit, reveals how significant this hand design was internally. Tesla engineers were not describing incremental progress. They were describing a fundamental leap in what robotic hands could do. The hand did not just work better than previous designs, it worked in a way that made previous robotic grippers look primitive by comparison. And then Tesla killed it. However, Musk said this week that the patented hand design is already obsolete, saying the team has moved on to a newer iteration that has not yet been publicly revealed. That statement is remarkable when you understand the timeline. International patents for the tendon-driven hand were published in mid-April 2026. Patent filings require detailed technical documentation, engineering drawings, and legal review. Companies do not file patents on technology they consider obsolete. Yet Elon Musk publicly stated the patented design is already outdated and that the team has moved to a completely different iteration, one nobody outside Tesla has seen. The question everyone is asking is why? Why discard a hand design that appeared to solve one of robotics' hardest problems? Why replace it before the world could even verify it worked? And what could the new design possibly offer that the tendon-driven system did not? The first possibility is manufacturing cost. A tendon-driven hand with 22 degrees of freedom might work perfectly in a lab, but if each hand costs tens of thousands of dollars, it will never scale. Tesla is not building a few hundred robots, it aims for massive production, targeting up to 1 million units annually at Fremont and potentially far more at Giga Texas. At that scale, every component must be manufacturable efficiently. Synthetic tendons may require specialized materials. Precision actuators could slow production. Assembly might require skilled labor instead of automation. Any of these issues could make the design economically unviable even if it works perfectly. Tesla's goal with Optimus is not a demo, it's a global-scale product. Musk has suggested a long-term target price of around $20,000 to $30,000 per robot. If the entire robot must fit that price range, the hands cannot be overly expensive, otherwise the business model collapses. The second possibility is durability. Tendon systems, even synthetic ones, can stretch, wear out, or fail under repeated stress. If internal testing showed the hands required frequent replacement, that would destroy their practicality. Optimus Gen 3 will first be deployed inside Tesla factories, performing repetitive and physically demanding tasks. These environments are harsh continuous operation, vibration, dust, and temperature changes. If the tendon-driven design could not survive long-term use, Tesla would have discovered that quickly and been forced to redesign. The third possibility is the most interesting. Tesla may have reduced the need for extreme mechanical complexity. Instead of relying on 22 degrees of freedom, they might be leveraging better AI. In robotics, there is always a trade-off between hardware complexity and software intelligence. You can build a highly complex hand with many moving parts, or a simpler hand powered by smarter AI. If Tesla made a breakthrough in control systems, it could achieve similar or better results with fewer mechanical components. This would reduce cost, improve reliability, and simplify manufacturing, all critical for scaling. There is also a fourth possibility. Tesla may have developed an entirely new actuation method, not tendons, not traditional motors. Something different, advanced materials, artificial muscles, or new actuator technologies. Any system that removes the need for tendon architecture while maintaining performance would be a major leap. At the same time, Tesla delayed the Optimus Gen 3 reveal. Musk confirmed the robot is already walking but needs finishing touches before being shown publicly. That phrase raises important questions. If the robot can walk, then the legs, balance, and core systems are functional. The main bottleneck appears to be the hands. And if the hands are holding back the reveal, it suggests the replacement design is extremely new, possibly still being refined. What makes this situation even more remarkable is the speed. Traditional robotics companies take years to iterate on hardware. Tesla appears to be moving in months. They designed a tendon-driven hand, filed patents, and then replaced it before those patents were even fully public. That level of iteration suggests either risk or confidence. Either Tesla is changing designs too quickly, or it has advanced simulation and testing systems that allow rapid validation. Given Tesla's strength in AI and simulation, the second explanation seems more likely. Investor interest reflects how critical this is. Over 1,000 questions were submitted ahead of Tesla's Q1 2026 earnings call, with top questions focused on Optimus production and capabilities. Investors are not just asking when the robot will arrive, they want to know if it can do real work. And that comes down to the hands. If Optimus Gen 3 can demonstrate human-level precision tasks like handling fragile objects or tightening bolts, it will prove real-world usefulness. These are not simple demos. They are core tests of whether a robot can replace human labor. And Tesla just abandoned a hand design that seemed capable of achieving those tasks. Which means whatever they are building now must be better or at least better aligned with real-world needs.